Well, good morning or good afternoon. Well, good morning or good afternoon, depending on where you are in the world. And welcome to our radio broadcast on service orchestration, the case for NETCONF and Yang. I have two great speakers with me today, Carl Moberg, who is Vice President of Technology at TLF Systems, and Jeff Mattson, who is Vice President of Engineering and Product Management at Juniper Networks. So welcome to you both. And I'd like to start by asking you, Carl, a very straightforward question. What are NETCONF and Yang?
That's a great opening question, Caroline. So NETCONF and Yang, actually the way I look at it, it's that it's the byproduct of the fact that the service provider community realized in the early 2000s that there was a big gap in the protocol set coming out of the large standardization organization. So NETCONF is actually a protocol that was developed as a response for requirements from service providers about getting a programmatic way of changing the configuration and operational state of the network. So it's a protocol that is explicitly designed for distributed control of networks. And Yang is actually its associated data modeling language, much like the SNMP MID language for monitoring. So they go hand in hand, and as I said, NETCONF is a protocol, and Yang is a language that describes what you can do with that protocol for particular network elements. And it's a direct response to the need for programmatic networks that emerged in the early 2000s from the service provider community.
Okay, so why are they so important? I mean, why are we here discussing them today?
That's another good question. So, I mean, the big thing, the big driver for it is the need to have scalable and robust ways of managing networks. And what that comes out of is that most service providers today and most ambitious network owners are fundamentally looking to replace manual processes. You know, they're tedious and they're pretty error-prone. Most service providers and large network owners, enterprises can tell you long horror stories about the fact that most of the network outages is actually based on what some call operator errors, which means that people are still mistyping things into the network. And in order to move away from that, of course, we need some sound technology to allow for a programmatic and automatic change and provisioning in the networks. And our CTO likes to liken this to what happened in the database world when SQL came about, when we could go from application-specific programmers for storage into relational database managers with an open and schema-driven access to the assets that we need to manage. And in this case, of course, that's networks.
Sure, and isn't one of the important features of NETCONF rather like the database world to which you've likened it, the fact that it supports network-wide transactional integrity, which, you know, the ability to program across multiple and automate that across multiple different machines with rollback features.
That's absolutely right, and it's really a fundamental aspect, and it's the realization of the necessity of that is actually part of this whole idea of going towards software-oriented networks, right? So it's something that the NETCONF protocol is actually borrowed from, let's say, 70s computer science. You know, this is not new at all to computer scientists and to software people. It's just that it's actually relatively new to the networking industry, and it's something that profoundly changes the way you can program for your networks and the way your network behaves in the face of changed configuration and provisioning. But it's really a fundamental change.
Okay, well, thank you for that opening. I'd like to turn to Jeff now and ask you, Jeff, if you agree with Carl, and perhaps you could tell us why NETCONF and Yang are important from a Juniper perspective.
Yes, we 100% agree with Carl. Juniper was heavily involved in the initial development of NETCONF, and we do support it on all of our devices now. What we're seeing lately, though, is we've been reapplying NETCONF and Yang, which were originally designed for control of routers. We're looking at control of other forms of equipment as well, CCAP, microwave, optical. And in doing so, what we can have is a common language across network elements. It allows us to coordinate service and provisioning changes across routers and non-routers alike. And NetConf and Yang give us a way to do this that is, transactionally safe, and also provides a very good interface into programmatic application infrastructure. So, Yang presents the changes to the network that need to be made in a way that's comfortable for programmers to be able to design new services around. So we think NetConf Yang will spring out of the router world and across the transport world as well. And, we'd like to leverage it to create well-integrated services between routers and these devices.
Okay, and I guess one of the important things about NetConf and Yang is the fact that they are standards. So, Carl, can you tell us a little bit about their heritage? I mean, where did these standards come from?
Sure. There's actually a little bit of drama behind it, as in every good, I guess, shift in technology. So as I mentioned before, there was a realization in the IETF, the Internet Engineering Task Force, in the early 2000s that no one, literally among the service providers, were using SNMPs to write configuration. So the IETF realized that there was a gap. Now, there was actually a little bit of a race there between Cisco, who wanted to or was about to suggest that we make their CLI the standard, and Juniper, who at that point had something called JunoScript, which, when you look at it, looks a whole lot like what NetConf became. So the JunoScript angle kind of became the winner. So we started the work on NetConf based off of JunoScript. And again, all of this was driven by a fairly well-documented set of requirements coming out of the service provider community. And it's also well-documented in a document called RFC 3535. So it's something you can find in the IETF history books if you Google for it or go to the IETF website. So that's kind of where it started. And, of course, key to success here is to build momentum behind it. So we were, ironically enough, lucky that most of the attempts of reinventing SNMP had failed, and the people that had battled around that were eager to or happy to join the NetConf and Yang momentum. So we got a lot of feedback and a lot of good input from the SNMP gray army, so to speak, people who had been at this for many, many years, joined the NetConf and Yang momentum, and fed us back a lot of good experience and a lot of good input into these definitions.
Okay, well, it's tempting to wonder whether the drama that you mentioned contributed to the fact that it seems to have taken rather a long time for the industry to adopt these standards.
Well, it's one of those things that I know people complain quite loudly about, and of course, having been part of this, I do get a little bit defensive, and I have to say that bringing these things to fruition, bringing a useful and robust protocol to do distributed change management, and to build a data modeling language for it is actually quite challenging. So, of course, yes, standard life cycle overhead does contribute to that, but it's not at all easy to get right. And get right in this sense means that we have to build something that people reasonably, can implement reasonably well, and has, looks like it's something that can be successful and useful. And we get a lot of scrutiny, during these life cycles from all angles, from the people with a strong applications background and certainly for people with a very strong security background. So there's a whole lot of work putting into that. And of course, yes, standardization life cycle does contribute to that, but not too much. So I tend to look at it at, like, we have spent a number of years of making it useful and taking experiences and putting it back into it. But yeah, it's taken us a good 4 or 5 years to bring it to fruition, and then we've had it in deployment, I believe, Juniper at least, for a couple of years. So think of it as well proven and well thought out, rather than something that took a long time.
Okay, well that's very interesting, and I'd like to drill down, if I may, on that sort of well thought out aspect. Why it's sort of well thought out compared to, say, some of the other protocols and approaches that people have been trying to apply to this big configuration problem. So, Jeff, what's different about NetConf compared to using REST or SOAP or Corba or SNMP, for example?
Well, that's a good question. By the way, I think this is a first where you hear the term drama and network management in the same sentence. This is so there are a lot of data interchange protocols available in the application world, and they all have their supporters and their benefits. Of the protocols you mentioned, there's one that was specifically designed for network management, and that's SNMP. And SNMP, Simple Network Management Protocol, was designed in the late 80s. And the constraints associated with managing network devices in the late 80s were quite different from, the problems we're trying to solve today. And I think, SNMP has been very, very successful in being able to, be a protocol that's designed to be very simple to implement, can run with very small code space, can run with a very, relatively inexpensive processors on really any type of network equipment. But it doesn't ask very much of the network element. It just, simply generally used for monitoring. It could be used for, setting some config parameters. And, a generation later, the industry looked at trends, looked at actual workflows that, network operators, network engineers were using, and, they saw that, CLI was a common way to actually manage routers, but CLIs have not been standardized, and they do not lend themselves to programmatic automation. And so NetConf Yang has been an attempt to take some of the virtues of that CLI-oriented workflow, but to get it in order using methods that will allow commonality between vendors and regularity that will allow sort of machines rather than just humans to understand CLI and to be able to program CLI very easily. So in that way, it's sort of a natural progression or natural adaptation for the way operators have been using devices. It also takes into account things that we, in the router world, we frankly ignored for quite a while that in the transport world were very important. So things like being able to, as Carl mentioned, to have a transactional model where we can coordinate multiple changes and issue them as an atomic transaction into the network. This has been part of networking for a very long time, but is something that has just finally sort of migrated into the routing world with NetConf and Yang. As far as the other data interchange protocols you mentioned, they're all attractive and useful for different forms of problem solving in the application domain, and some of them can be adapted, to using NetConf and Yang. But NetConf Yang is built from the ground up to solve this one particular problem of configuration management in networks, no more, no less. And so in that way, it's a very clean tool for providing that type of service.
Okay.
I tend to agree with what Jeff said here, and the amount of questions I get about how does NetConf compare with REST, SOAP, and Corba, for example, is quite extensive. And of course, just tagging along with Jeff here, NetConf is actually an entire stack, right? It provides a lot of semantics that is specific to this problem space, while REST, for example, is more of an architectural principle, and SOAP and Corba is more like an envelope for communicating data. NetConf provides also semantics that is directly related to configuration of various types of devices with a conceptual database model and things like that. So you can actually, like Jeff said, you can reinvent NetConf actually on top of SOAP or on top of Corba if you like, but that's not really the point, right? So a big conceptual difference between them.
Hello?
Hello.
Sorry, we seem to have lost Carl, I think.
I'm here.
You're still here, Jeff. Yes, we were just saying, actually, at the beginning of the... Sorry, Carl.
Yeah, can you hear me?
I can hear you, yes.
Okay. Yeah, and I can hear Carl as well. We were just talking about how, talking about advanced networking concepts always causes some sort of technical problem during the presentation. And I guess this is an example of it.
This is an absolute example of it. Are you back, Carl?
I'm here. Absolutely, I'm here.
Okay, sorry. We had a drop. Well, I couldn't hear you for a time, so okay. Apologies for that. Yeah.
No problem.
Okay, so you were giving some very good reasons as to why you don't really want to reinvent the wheel. I mean, there's NetConf exists already. You can use RESTful SOAP to do the same things or to build the same things, but why reinvent the wheel? I think you were saying.
That's right. That's exactly right. And NetConf is actually a semantically rich protocol stack, so it provides all parts of what a protocol needs to do for this particular challenge, right? So it's much more than just a transport. It actually provides the basic operations, the basic semantics of what you need for this. Okay.
Well, you've convinced me that NetConf is a well-proven protocol that really addresses a genuine problem in this domain. But how extensive is the ecosystem around NetConf and Yang? So we have Geoff here from Juniper, but what other equipment vendors, service providers, software houses are involved in adopting it?
Oh, okay. So the way I look at it is actually there's three, let's say, entities or three types of companies that need to move here. First of all, and of course, fundamentally, the major burden of implementing this falls on the equipment providers. Of course, again, Juniper was really early out the gates. They've had a very solid implementation for many years. Cisco has one that they're actually kind of re-releasing in the context of their SDN pushes here, so look to them over the couple of coming months here for a more complete support, including Yang. There's a wide variety of, let's say, tier 2 equipment providers in various parts of our industry, including companies like NetOptics, actually Ericsson and others that actually have NetConf and Yang support in their parts of their portfolio. So that's really important. And of course, secondly, you need software for it, right? You need software in order to use this protocol. So there's a wide variety of both open source and proprietary software, of course, from companies like KLF, but also what's called the Piang open source project for parsers and validators. There are editors and IDEs or software development kits from companies like MGSoft. And, of course, the interest from the service providers is growing quite rapidly, which can be seen in standards-defining organizations. So there's actually Yang models for various things coming out of standard organizations like Cable Labs, the Metro Ethernet Forum. Certainly in the ONF, I'm doing quite a bit of work with these things. The Open Daylight project certainly has very profound support for Yang. So I'd say over time it's been building. It's one of these long and persistent build-ups. And we're definitely getting there, both with the software supporting the equipment and certainly with the interest coming out of the service providers.
Okay, well, that's very encouraging. And Geoff, I wonder if you could comment on the value of an ecosystem from Juniper's perspective. I mean, doesn't it make it more difficult for you to differentiate the company competitively?
That's an excellent question. And on the contrary, actually, it makes it much easier for us to bring out the value of the router itself. So you see, we invest tens of millions of dollars in making ASICs that are able to process traffic in the data path very well in order to shape traffic and to apply services to traffic. And we have protocols that allow us to talk to other routers that are pretty well developed at this point. But as soon as we want to coordinate a service with something that's not a router, with a CCAP device or microwave or optical, for instance, there are very, very primitive mechanisms available, if any. And if there is a protocol that allows us to talk to a transport device, it's usually specific to that particular domain. And what NetConf Yang offers is the possibility of a way for our routers to be able to coordinate services and coordinate configuration changes with non-routing devices that are adjacent to it. So we could talk to the optical layer that we're plugging into. We could talk to downstream microwave devices. We could talk to CCAP devices and provision subscribers. And this actually brings out the value in our routers. This actually brings out the value of the things that we can actually do in the data path better by having a common management and control plane across multiple network devices. As far as the ecosystem is concerned, I think what we've also noticed is, in addition to working with some partners in these areas, and we're going to roll out some announcements about that over the next quarter, I think what we've also noticed is when we talk to startups who are developing network elements, whether they be router-oriented, IP-oriented, or transport-oriented. And we found that NetConf-Yang is the go-to protocol, and new devices tend to be developed with at least some support for NetConf-Yang, if not, using NetConf-Yang exclusively as their management protocol. So we definitely think it's taking hold and emerging, not just in the standards organizations that Carl mentioned, but also the vendor community seems to be picking up on it. And of course, we've received a lot of interest from our service provider customers as well. Okay, so Carl, both you and Jeff have alluded to software-defined networking, I think. You've mentioned Open Daylight. Jeff's been talking about having a centralized and managed control plane, which is kind of SDN speak. How applicable are NetConf and Yang to this emerging story about software-defined networking?
Well, to be diplomatic about it, of course, the term SDN is constantly being kind of repurposed and maybe reinterpreted. So if you want to back down and think about SDN as a way of programmatically, influence or change your network, and for most of our customers, what the word hidden in SDN is actually automation, right? So OpenFlow being kind of the horse before the cart, at least in the early days of SDN, is a way of manipulating something that's very, very close to the hardware. It's actually a way of manipulating your switch pipeline, very, very, hardware close. And for many of the scenarios, or for many of the environments we see people wanting to apply network automation, that is actually too granular. That's too fine-grained of a control. And NetConf is usually something that you apply to, let's say, the network application layer. So in Juniper's case, of course, it's on the same abstraction layer as the CLI and as the SNMP, which is an abstraction layer that most service provider operation teams are very comfortable with. So it gives them, it's more of a way of influencing their existing network, a way of programmatically controlling and automating their existing networks on an abstraction layer that is understandable for the common man, which most of OpenFlow actually isn't. So if you want to be able to extend SDN into saying automating and programmatically controlling the existing networks, I think it's going to play a huge role, right? I think it's going to play a huge role. It's not going to make OpenFlow go away. It's not going to make other emerging things like I2RS or interface and the routing system go away. It's just going to be a complementary protocol that you can use for the types of things that require something of a higher abstraction layer programmability in existing and also in future networks. And as Jeff said, it's not at all constrained to physical routing and switching. We see people applying it to virtual appliances that are doing other things like firewalls, things like load balancers, things that are ephemeral features sitting on top of a transport network. So I think it's got the position, it's got the location in people's mind here that can make huge impact on the way people actually roll out programmable and automatically managed network in an SDN fashion. So I think it's going to be big.
Yeah, this is Jeff. I agree with Carl completely, and I actually think that the default way that SDN is presented in networks now is usually there's some sort of point protocol which has a specific purpose. For instance, the OpenFlow line protocol in the case of the ONF architecture, or PCE for controlling LSPs. Then it will be supplemented with NetConf-Yang to do everything else, basically. So if you want to automate a network, there may be some parts that you want to provision through or activate through a very specific, tightly defined protocol. But then for everything else, for the general management, the programmatic way to do it, the default method that SDN standardization groups tend to refer to is NetConf-Yang. If you'll forgive me making an overgeneralization, I think that's a fairly simple way of looking at it. It tends to be true.
Okay, well that's extremely helpful, and I think the concept of NetConf as a configuration, as a protocol for programmability, I think that's fairly easy to grasp. But Yang models, what do they do? How is the sort of Yang-driven network going to, or these Yang models going to give us an opportunity really to sort of compose and chain network services in a flexible way?
So actually the whole concept of schema or data modeling languages is, for large parts of our industry, a relatively new thing, at least in its in the useful form that Yang takes. So what it is, it's the way I usually start describing it is that it's a contract language from, for example, Jeff's products to the management software, right? You can actually ask a Junos-driven box, what is your data model? And it would give you an entire description of all the parameters, its semantics, and its relations in a formal way that you can feed into software. So you can actually synthesize, if you like, control software from that, right? So it becomes the contract language from the network elements to the software. And the software industry knows what to do with these things and have been doing it for many, many years. And what we're doing now is that we're slowly trying to apply these well-known things to the network management industry. So when we start building higher-level services, like the one I think you mentioned, this is going to be a fundamental building block. And you'll see that many attempts of standardizing, for example, service chaining or network functions virtualization will drive a very strong requirement of such a contract language that will allow the software to stitch them together, to put together higher order services based on these fundamental building blocks of contracts coming out of the network elements, be they physical or virtual. It's to the point where I have a hard time seeing how it can be done otherwise, right? If you don't have a formal contract language, there's going to be a lot of ad hoc code and a lot of ad hoc things, and will drive more integration projects than useful services. Yeah.
Yes, and having a standardized language is going to be extremely helpful here, rather than a very sort of flexible or proprietary scripting language.
That's right. We can build point solutions that work off of that and come out of the somewhat, heavy integration-heavy world that we're in right now and reduce that. Okay,
well, we're coming to almost to the end of the show. So I just want to get in a quick question here about quantitative benefits, because conceptually these things sound great, but in terms of quantitative benefits, Geoff, that your customers, or that you as a network equipment provider or your customers will gain from using NETCONF and Yang, what are they? What do they look like?
Well, we would look at those benefits in terms of a total solution. So some of the ways that we're creating solutions that attack different market segments, like, for instance, MSO segment, we've been able to put together new architectures that have a significant, 80% reduction in power consumption, for instance. And we can do that using NETCONF Yang as part of that, because NETCONF Yang is able to coordinate changes across various network elements and allows us to reduce some of the redundancy in the design in that way. So, sometimes it's hard to isolate a specific benefit to NETCONF Yang itself, but as a solution enabler, we can quantify a very, very significant cost savings and OpEx reductions for our customers, and it also enables a much greater flexibility in terms of service agility.
Right. Well, service agility and cost reduction are always news to service providers' ears. I mean, Carl, do you have anything to add there to terms of benefits?
Yeah, no, absolutely. And I think, for us, also being a little bit of a careful Swedish person here, we don't have, much in terms of numbers yet, but there's two things that really stand out in the conversations we have with service providers and large data centers that are looking to leverage things like NETCONF and Yang. And it's first of all, of course, that they must get humans out of the loop, right? That is just very important. Again, some of the guidance figures we have says that 60% of the outages in major networks are still driven by people mistyping things or translating things wrong from printed matter into their console, right? And the second thing is actually the speed of change, right? How fast can you change your network? Well, if you stick a human in the provisioning loop, that's going to be fairly slow. With a programmatic and robust protocol like NETCONF and Yang, of course, that frequency can come up very, very, very high. So again, I think it's a fundamental change in the way many network owners will look at changing their network. And I think the kind of key indicators and the numbers around this will emerge as they deploy this and kind of close the control loop and look at the side effects of that. So more about that to come for sure over the coming quarters and probably over the coming years.
Sure, and so this really helps with the ability to drive down the huge time it currently takes to configure very complex network services.
Yeah.
Sure. Okay, well, for those of you in the audience who would like to hear more on this topic, TLF Systems will be hosting a town hall event at Mobile World Congress. And just before we go, Carl, would you like to tell us a little more about this event?
Absolutely. So from our point of view, the time is right actually to bring some of the industry luminaries, including, for example, my co-presenter here today, Jeff, with the representatives from Cisco and Deutsche Telekom and others for a town hall meeting during the Mobile World Congress in Barcelona in a couple of weeks. So for the Monday evening, we're actually we have a separate kind of sit-down panel-style meeting where we will discuss and share experiences with what we believe NetConf and Yang can bring. So there is a sign-up form for that at our website, tail-f.com. So go and take a look at that and join us in Barcelona for what I think will be an even deeper and perhaps more social event around these things, also hosted by you, Caroline. So I'm looking forward to that.
Indeed, as I am too. I think it's going to be tremendous. So look forward to meeting some of the audience, or hopefully a large number of the audience there. Well, we've reached the end of today's live broadcast, but Carl, Jeff and I will shortly be decamping to the message board on the Light Reading site to answer questions from the audience. And I just had a quick look, and there are lots of questions there for you, Carl and Jeff, to get your teeth into. So do join us there for a lively Q&A. Thank you very much to Carl and Jeff, and see you in the live chat in a moment. Goodbye.